All right, in this video, we're going to look at explicitly defined functions. Now, an explicitly defined function basically provides you with an expression that is dependently solely on the value of n. So if I wanted to know the value of any term in a sequence, all I need to do is plug in n. It doesn't depend on what a previous term was or a next term, only the value of n. I substitute in whatever the index number is of the term I want to find, and it's going to tell me what its value is. Now, the thing to keep in mind is it seems like it makes you wonder why all sequences are not defined this way. And it brings us to an important concept that a lot of time and effort is studying in higher level mathematics. That there are some sequences that just cannot be defined explicitly. They have to be defined recursively. Now, let's look at a couple of problems where we just want to find the first four terms in an explicitly defined sequence. Now, notice here at this first one. So if I'm using this set notation here, what is inside of the set is the expression, or the explicitly defined expression, where if I want to know a specific term, I just put in a number for the n's. Well, when it's defined this way, the first number that you put in is the bottom number, and the last number that you'll put in here is the top number, and I'm going to generate my terms. So my first term is going to be when I put in 1 for the n's, and my second term is going to be when I put in 2 for the n's. My third term is going to be when I put in 3 for the n's, and so forth, all the way until I get my first four terms. And so my first term is going to be 1 to the 1. First term is going to be 1 to the 1 power. Second term will be 2 to the second. Third term will be 3 to the third. Fourth term would be 4 to the 4th power. And I would just evaluate those. And so my first four numbers in this sequence would be 1, 4, 27, and 256. All right, let's look here at this second expression. So the expression b of n, it will generate a sequence starting from 1 to infinity, where b of n is the nth digit of pi. We just want to find the first four terms of this sequence. So when n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4. So it's the nth digit of pi. So when n is equal to 1, b of n is equal to 3. When n is equal to 2, because we actually don't have an equation to generate all the numbers of pi, that'd be the second digit of pi, which would be 1. You think 3.14 or 159, whatever. So the third digit of pi would be 4, so 3.14. And the fourth digit of pi is going to be a 1. And so if I wrote it out, we'd have 3, 1, 4, 1. And then it would just continue on from there. Now let's look at the next explicitly defined sequence. So a of n is equal to n minus 1 over n squared. And I want to find the first four terms. Well, if we're not told, we're going to assume that the first term is going to be when n is equal to 1. So a1 is going to equal 1 minus 1 over 1 squared. The second term, a2, would be equal to 2 minus 1 over 2 squared. The third term would be equal to 3 minus 1 over 3 squared. And then the fourth term, when I put in 4 for the n's, would be equal to 4 minus 1 over 4 squared. And then we would evaluate those. And then we could write this out in terms of the first four numbers that we would have. And so we'd wind up having 0, 1/4, then we'd have 2/9, and then we would have 3/16 if I'm just writing the first four numbers. Now let's look at this one. So I want to write out the first four numbers of this sequence and the way it's defined. Now here's the thing to note is the first term number is not a1 in this case. It's going to be when n is equal to 0. That's my first term. And then we keep going to infinity, but we're only writing out the first four numbers. And so the first number in this case would be n is 0, and then I'd go to n is 1, and then n is 2, and then n is 3 to get my values from there. And so our first term, we'd have negative 1 to the 0 minus 1 power over 3 to the 0. Our second term would be negative 1 to the 0 power over 3 to the 1. And then we'd have negative 1 to the 1 power over 3 squared. And we'd have negative 1, I'm just putting in the n numbers for n, to the second power over 3 to the third, and then we would evaluate each of those. And we'd get our expanded form of this explicitly defined sequence, and we'd have -1, 1/3, -1 over 9, 1 over 27. And then this would continue on forever because the top number would be infinity.